Thanks for having us, Martin, and thanks for the introduction. We apologize for not showing up live, but we had a bit of a scheduling conflict. We've chosen to talk a little bit about how we have used AI to work with sustainable construction in a couple of cases. And I'm going to start off by showing some of the different cases, and Peter's going to talk about a specific project that we have done. We come from two different companies, but we collaborate every time we get a chance, I will say. We come from Denmark, and in Denmark, there's a very strong focus on sustainable construction. It's most of the Nordics. There's been a big push, especially over the last 3-4 years. And that means we're talking radically lowered CO2 footprints. We're talking circular construction. We're talking upcycling of components and materials. And the thing is, we don't have, even though we've been working with sustainability in construction for the last 20-25 years, we don't have a lot of scalable solutions, and we don't have a lot of data when it comes to how can we reduce our CO2 footprint with 75%, which is actually what we're looking at, and how can we feed our projects with upcycled components. So we're looking at how can we datafy the existing projects that we have. And sustainability is very much a data and numbers game, especially because we need to track our emissions and we need to track our how we're completing with our targets, because it's actually easier to get more money and more time than it is to get more CO2 on a project. So once you go over the limits, you kind of busted the project for the next couple of 100 years. So these are some of the cases where we've used AI to solve some of these conundrums we've had. This is an example from a project where we're building 200,000 square meters of wooden houses on actually an old landfill. And the ground there is super contaminated. So we wanted to minimize the number of boreholes that we did and still get a good picture of what was in the ground. So we did the boreholes, and we found some other boreholes, a couple of hundred other boreholes in the public data, and we built a model that could do a prediction of what was in the ground and use that to plan the work and put the placement of the buildings in the area. So another example is from energy refurbishment, where we've used some generative adversarial networks to kind of fight over the best solutions. So we had a neural network come up with the best way to optimize the build, and then we had actually an expert system that would kind of kick down these different solutions, looking at what they would look like when we started using them. So there was a fight between what's easier to build and what's better in the operations phase. Another example is we're looking to optimize operations and maintenance for buildings, and we wanted to go in and look at campaigned maintenance rather than the usual ambulance service that we have when it comes to maintenance, and we wanted to make sure that we weren't renovating something that shouldn't be renovated. So we worked with some engineers that do inspections of roofs, especially, because that's one of the major costs to these old buildings. And they do these drone flyovers. And we built an AI that can take these drone flights and turn them into heat maps. So we get an idea of what are the critical areas in these roofs based on the movies that we got from the drone. And we actually pushed it a bit further. We took a number of old predictive maintenance plans and also resource mappings. And we had ChatGPT actually write out the predictive maintenance plans and the resource plans for a number of different buildings. So we could have a bit more data to work with. I can tell you for the resource plans, it was quite interesting because what we could see is normally people don't write that much, but ChatGPT is a little bit more chatty than engineers. So we actually got better descriptions of the conditions of the components than we got in the normal reports. We used some of this tech in a house project that Channing did. They wanted to rebuild their office and wanted to maximize the number of reused materials. So we built a model first we scanned and built a model of their existing building, and we went out to a number of construction sites that were ready for demolition or rebuilds, and scanned a number of them. And using AI segmentation, we could turn a number of the different components into BIM objects that we could then use in the design and place in the models using scripts. And they ended up having a refurbishment that was over 90, I think it's 93% reused materials in that house. So we also put it all together here. We have basically a generative design of some building blocks. And as we're changing the designs of them, we get a prediction of the LCA for the building, both for the environmental cost, you can say, of what it will take to build, but also of the operations. So as we look at different scenarios and different designs, we can get a prediction of the CO2 footprint and the CO2 and emissions footprint for the operations. So a number of different ways we've used AI to datafy geometry and existing conditions.
Thank you. Yes, good morning. Here's in the evening, but my name is Peter. I'm not a colleague of Niels's, but we do collaborate quite a lot. I am often representing the client side here in Denmark, and this particular project I will just introduce you to briefly is a project that we have been, or I've been heading it, and Niels have been helping me in order to make a demonstration on how to utilize digital tools in various ways to construct a real house. And what we're doing here, I'm working on behalf of a philanthropic organization. So this is not a commercial building project at all. And we're basically building 5 houses here next to each other. They're almost the same. They're very standard Danish developments. They're 5 stories high. They're small. They have one apartment on each level. They are all certified to a certain DGNB standard. They cost more or less the same. They lie and have to adapt to the same local plan act, stuff like that. But they all, because we are very, very curious, this philanthropic organization here is curious in finding solution on how we can minimize the CO2 footprint from the Danish building sector. And the reason for that might be obvious for you and us, but here in Denmark, the construction sector stands for about 40% of the national CO2 emissions. So there is a huge, and since we are a Scandinavian country, there is of course a huge aspiration for actually controlling those emissions and trying to bring them down. So these 5 houses, they do experiment with various tools in how to bring down CO2. I'm sorry that this particular slide is in Danish, but I understand. I think you can understand that the 2 to the right, or to the left, sorry, is a digital house. That's the one we will discuss about here. We're trying to utilize digital tools. What will it do? How can we work with those in order to focus on CO2 emissions and bring them down? We do a prefabrication house to do the same. And then we do 3 material houses, one in bricks, one in wood, and one in concrete. When all these houses are done and finally built up, we can compare them to each other. We'll see how long time it took, how much CO2 was embodied, what were the costs, what did the customers say in the end when they have to be inhabited by real people in the end. So that is sort of a rather one-of-a-kind building experiment to a one-to-one scale. And the reason for what basically what we're trying to focus on, because you can diminish the CO2 footprint in various ways. What we are trying to focus on here is the reduction of waste errors in the construction. We found out that about 10% of all building projects here, they are thrown into the waste basket before they are commissioned. Meaning that we basically not build 1 house. Every time we build a house, we build 1.1 house. Some even say we build 1.2 or even 1.3 houses. That's the amount of waste we throw over the wall before we finally open our houses. Can you slip a slide? Thanks. Yes. in Denmark, there is a lot of requirements, and when we're talking the CO2 and the sustainability agenda, there's of course the targets we have in the national legislation, the building regulations. We have the EU rolling in over us, where they have a taxonomy. So if you're a business of a certain size, you need to report on on what your impact is. We often use a German certification system we call DGNB. Can't remember exactly what it is, Deutsches something. But anyway, it's a sustainability certification system, a little bit comparable to your LEED system, but more German. We also focus very much on life cycle analysis or life cycle cost. We have to present those to the authorities to get taken into use permits. We discuss EPDs and etc. You can see it here. So we actually have a number of tools, some of them more or less digital, but the methods are in use. Can you scroll one more, Niels?
Yes, sir.
So here, what we did here on this particular house is where we started actually to use some AI generated design to find out what the most optimal footprint of the house was. As you can see, this is a very early sketch or drawing rendering of the houses and lying next to each other. But as they basically have the same purpose, they are small housing units with a few bedrooms and a living room and a kitchen and a bathroom. We could use AI to generate the design and find out the optimal footprint of the house, in order when we put in a number of tasks it should solve, like the daylight intake, noise reduction, stuff like that. One more. We also use a number of tools when we are actually building on site in order to measure energy consumption. We were using, you can say, we have of course energy consumption. We also water consumption and components that we could measure the CO2 emissions in real time, and also using predictive models actually to say how is this going to be transported into the future. We expect that is in that particular part of the CO2 emissions are not really taken care of and taken into consideration so much yet over here. We're trying to focus on it, what the construction side has of impact on the sustainability agenda, and it means actually quite a lot more than you would imagine. Basically, here we have now a national target saying that a house like that one needs to comply with about 7 kilos of CO2 per square meters, but 1.5 of those are coming from construction, from the site itself. So it does have a significant impact. It's not only a matter of finding out whether you want to reuse bricks or you want to build with wood, but you also need to take care of what is actually going on when you're really building. One more, Niels. So the result is here. It's rather clear. The two columns, or the two schemes here. The one to the left is the result, the final LCA calculation of the house, and the one to the most left is the house that we built, and the other one is a reference house. You might wonder what a reference house is, because we've not built a similar house next to it, but we did, by the help of a Danish university, create a baseline building that we're comparing this to. So the only thing that is different here is the orange part of the calculation, the blue part in the bottom being the product, the actual house. The orange part is the process, the gray part is the usage of the house, and the light blue is the end of lifetime. And by working with these methods and these tools that we did save 12% in CO2, and that was by building exactly the same house. By the way, 10% or 15% faster and 8% below budget, and handed over on time with 0 defects. And also with a saving of about 12% on the CO2. So it's rather obvious that there are clear advantages if you want to plan and use digital tools, that you can actually obtain not only a better process, a faster building project. It might even be a slightly cheaper, but also significant savings in your CO2 emissions. The columns to the right are sort of just the orange parts that are just exploded out. So it is consisting of 3 components: transport, waste and energy uses on the site. And the thing that we are focusing on is here's the waste, is the orange part. Again, you see, you probably brought that down to with about 40 to 60% just by not throwing out building materials in the same manner and speed that other buildings projects do here. Was that the last one, Niels? Yeah, here those were the results, as I just told you. Besides the CO2, we did build 8% below budget, 15% faster. That might be even higher because all building projects over here are delivered after time schedule. So that might, and the general delay is about 5%. So you can probably add that to the 15. We did have 0 defects, and I mean 0 defects, when we were handed over the project, and the 12% CO2 I just told you about. I think that was it, wasn't it? That was a speed talk.